So today we're covering lesson 3.2, and you can tell by the title we're going to be doing solving quadratic equations by graphing. I thought I would just make a little connection here before we jump right into the lesson. This lesson that we're doing today, there's a lot of parallel to what we were doing in lesson 3.1. As a matter of fact, it's a big part of what we've already learned to do in graphing quadratic functions. Let me tie it into where we've been maybe in our Algebra 1 experience. Let's just take this blue equation, for example. And in Algebra 1, you may have been told to solve this quadratic equation. You've been taught a couple or three different methods for solving quadratic equations, one of which is the graphing method. The factoring method. And this happens to factor because there are factors of 3 that add up to 4. And hopefully you remember this, factoring this quadratic trinomial as such. And the factoring then leads us to the 2 solutions. There are 2 numbers that we could plug in for x to make this equation equal 0, aka the solution. And one of those numbers would be -3. And the other one would be -1. So our 2 solutions to this equation, this quadratic equation, are -3 and -1. All right, so let's jump over here to this red example and apply what we learned in lesson 3.1. Let's graph this quadratic function. Notice the difference. This is equal to 0, and this is y equals x squared plus 4x plus 3. This is a quadratic function that we need to show all of the x, y coordinates of this particular graph. And so the way we do that is we're going to find, first of all, the AOS, opposite of b over 2a. And so hopefully you can probably do that mentally. The opposite of 4 over 2 is -2. So we have symmetry around the line x equals -2. There. Our vertex is on that line, so to find the vertex, we just place -2 in for x in this function. And hopefully you can tell we're going to get 4 minus 8, which is -4, plus 3, that's -1. So the vertex is the point -2, -1. All right, do those points in blue to make them stand out a little bit. All right, so there's our vertex, -2, -1. Our y-intercept is 3, and symmetry allows me to make another point on the other side of this dotted line. So 2 places to the right at the y-intercept is a point. So from the AOS 2 places to the left, I have another point on the graph. And then we typically do some inputs to generate some other points. So let's just say, for example, my next available input here, I don't have any y value for x is -1. So let's let x be -1. So -1 squared is 1. That makes -4, which is -3 plus 3. Look at that. We get 0. And if I match it up on the other side of the AOS, I also get 0. Well, isn't that interesting? That the x-intercepts for the graph just happen to be the solutions to the quadratic equation. And that's just kind of a connection to why we're doing what we're doing. All right, so today's focus is to take what we learned in lesson 3.1, sketch the graph, and if there is a solution, it will be where the parabola crosses the x-axis. Sometimes that's easy to see. Other times we're going to have to estimate it. And then if the graph never crosses the x-axis, and sometimes that happens, then there is no solution. All right, so I just wanted to give you that little preview as to where this lesson is going. And so let's get into an example. All right, so it starts off much like you did in the previous lesson. First of all, however, notice that this equation is not equal to 0, and so your first move needs to make any equation, quadratic equation, equal to 0 before you solve them. We are solving quadratic equations. We just happen to be doing it using the graphing method. All right, so it's still true that we need to make this quadratic equation equal to 0. And now let's see if we can identify the AOS, all right? Opposite of B over 2 times A, right up at 30. 3x. Okay. All right, so opposite of B, -3 over 2 times 2. So the AOS is going to be x equals 3/4. I'm just going to go ahead and sketch that real quick. And now we're going to find the vertex, which is on that x equals 3/4 line. And we do that by plugging 3/4 in for x. And so if you've got your calculator, hopefully you do, you can make, if you like, you can make 3/4 be 0.75. And we are turning to our calculator, and we're going to see what the y-coordinate of the vertex is. All right, so hopefully you got negative 20.125. So that tells me that my y-axis units are going to have to be changed in order to make this fit. And so I'm just going to do the y-axis in 2s. I'm going to leave the x-axis alone. And so let's see if we can plot our vertex now. And so down this line, we're going to go down 20 and then just a little bit more. So that's 20 and then just a little bit beyond that. I'm going to call that my vertex. Okay, another point that I can plot on my graph is the y-intercept, and that's negative 19. It's this constant. So negative 19, if this is negative 20, then negative 19 obviously is halfway. And we can match it up, so that's 3/4 of the way over from the AOS. So I need another point 3/4 of the way over on the other side. Okay, now we're going to just do some inputs, outputs using our calculator. So let's take, for example, what is 2? If we input 2, we got 1.5 by virtue of the matching up the y-intercept. We know what 1.5 is. That should be negative 19. So let's just go ahead and just see what this graph is going to do. So input 2 into your function, and hopefully you were able to get negative 17. So 2, negative 17, and that's right there. And that's 1 1/4 away, or you could say 5/4. So this is 3/4 plus 2/4, 5/4. All right, so let's do input 3. Remember, the whole goal here is where are we going to cross the x-axis? And I want to get as precise to that as I can. I don't want to just do a random drawing up this way. I'm going to get closer and closer with inputs until I have a pretty good idea of where this is actually going to happen. So let's input 3 in your calculator. And that should be output negative 10. Very good. So here we are, and we'll just match that up. That's 2 1/4. And we match it up on the other side. And so let's keep going. This time we'll input 4 and see what we get. So hopefully you just keep that function, obviously, in your calculator. You can just go up and type over the inputs. Sure that's what you're doing. And the output is positive 1. All right, so that's good information. So what I'm told here, and let's go ahead and match this up. All right, so we have this graph. I'll just go ahead and try to sketch it my best. So do you notice that between x equals 3, that was a negative, and x equals 4 was a positive. we should be crossing the x-axis between those two x's. Yeah, it's terrible, but... And so our solutions aren't exactly numbers that we can look at the graph and say, oh yeah, that looks like 2, or that looks like -5. They are, they're going to have to be approximate. If you look at your book, the directions, it says to solve each equation if exact roots, that's just another way of saying the solutions, or x-intercepts. If they cannot be found, state the consecutive integers between which the roots are located. So in cases like this, you're just going to say something like this. We have roots between -2 and -3. Say in order from left to right, -3 and -2, and we also have roots or solution between 3 and 4. Okay, so I don't want to belabor this, but that's really what you're going to be doing on the, I just gave you 4 of these to do. And this is the process. You're going to sketch the graph just like you learned. Look for where, if you cross the x-axis, where does that happen? And in cases like this where it's not exactly evident by the graph, then you're going to state the consecutive integers between which the roots do occur. Okay? So I'm going to skip number 2, and I'm going to go to number 3 just to kind of give you a heads up. Again, just go ahead and work on trying to find your AOS. Opposite will be over 2a. It's not yet equal to 0, so we need to do that first. And if I did opposite of b over 2a, I would get -8 over 4. And obviously that's going to be positive 2. That's -2, which is the opposite. So the AOS will be positive 2. And now when I plug in to find the vertex, I'm going to put 2 in for x. So let's see what we get in our calculator. All right, so let's see. 4 times 2 is 8. Minus 16 is -8. Plus 32 is 24. Okay, so the point 224 is way up here. Okay, and if you go back and remember what we learned about with reflections, this parabola has to open up forever. Well, this is the vertex, and it's got to open up forever from that vertex. So you don't really have to sketch the graph here if you can get to this point and tell that this parabola is never going to cross the x-axis. And if that's the case, then this is a no solution. Okay, so just be on the lookout for any cases like that. All right, so I'm going to get you set up on a couple of word problems. I'm not going to do these entirely. I just want to make sure you understand how you can do them. I think you can. So number 13, how long will it take an object to fall from the roof of a building 400 feet above the ground? And t is the time in seconds, and the initial height is h sub 0. Well, they told you the roof is 400 feet above the ground, and that's another way of saying the initial height. So right away, we can go ahead and make this height function say this. All right, so once again, how long will it take an object to fall from the roof? In other words, how long will it take to hit the ground? It's another way of expressing that. And when the object is on the ground, it's at height 0 feet. H represents height in feet. And so we're going to say, let this equal 0. And basically solve it. Solve for t. So I'm going to leave that part up to you. In cases like this, if you should happen to get a negative, a quadratic typically will give you two different answers. And if one of them happens to be negative, then that one doesn't count because we can't have negative seconds. So see if you can solve this either by factoring, or if you want to use the quadratic formula, I'll leave that up to you. It does factor, so give you a little hint there. You might want to factor out GCF and then take it from there. Okay, another problem, very similar, is this water hose problem on number 50. A water hose can spray water at an initial velocity of 40 feet per second. And here's our height formula, height function. Height, h of t is the height of water in feet. V sub 0 is the initial velocity. So again, they told us that the initial velocity is 40 feet per second. So let's just go ahead and write this as 40t minus 16t squared. So it's kind of similar to the previous problem. How long will it take the water to hit the nozzle on the way down? So in other words, it shoots up, and obviously because of gravity, it's going to come back down. So when it comes back down, it's at height 0. So solve for how long it takes. There's really going to be 2 times because initially it's at 0. And so you're going to get a t of 0 when it's at 0 feet high after 0 seconds. But then it should take a certain amount of seconds to come back. You know, it goes up and it comes back down. So see if you can, like you did on the previous one, this one also factors. You could solve by factoring. See if you can come up with your answer on how long will it take, how many seconds will it take for it to come back and hit the nozzle. Okay, this one, anytime you're asked to find the maximum height or the minimum, maximum or minimum of these quadratic functions, that's going to involve finding the vertex. Okay, so basically, I'll just kind of help you out here. This is going to be the other way. I'm sorry, it's negative. All right, so that's right. We're going to find this very highest point. And the way we find the vertex is we first find the AOS, opposite of B over 2A, find that number, and then plug that number back into the function for t. So when you find the AOS in this particular problem, you're finding t. Right? How long does it take? How many seconds does it take to reach this highest point? And then when you plug that number back in to this function for t, in both cases, you'll find the height. And that's what it's asking for. Now the trick here is, assuming the nozzle is 5 feet up, so you're going to have to go ahead and use your formula, find h, or find h of t, the height, and then you're going to have to add 5 to that. All right, that's what this is referring to. All right, the function has not been adjusted for the fact that the nozzle is 5 feet up off the ground initially. All right, so find AOS, plug it in for t to get the height, and then whatever that number is plus 5 will be your maximum height of the water. All right, so I reduced your assignment down to just those 9 problems, and I hope that helps you. And this is going to complete the lesson. So we did a short lesson and a short amount of homework problems compared to what I had originally. And if you have any questions, let me know.